You know, how do you use graphs and tables to understand science? Well, first let's talk about the types of graphs. Hopefully you remember that there are 3 different major types of graphs. There are some others that you've probably heard about in math, but for science purposes, we'll be using these 3. One is called a line graph, and that shows the change over periods of time. These periods of time could either be small or large. It just depends on the graph. You could also have a circle or what we call a pie graph or pie chart. That compares parts of a whole. The last type of graph that we're really going to use in science class is a bar graph, or sometimes we call it a histogram. We use a histogram or a bar graph to compare different groups or change over long periods of time. Notice that both a line and a bar graph show change over time, but the only one that can do both is a line graph. So in order to understand, let's take a look. What type of graph do you think this is? A line, a circle, or a bar? Hopefully you said a line graph. Notice that there are several points where the data is plotted and lines drawn in between. How about this? Good, that's a circle graph. Next, this is an example of a bar graph. Okay, now that we understand those, let's get into more details with a specific set of data. So back in the 1800s, there was an island called Krakatau, which experienced a violent volcanic eruption. And everything on the island was destroyed. So all of the living organisms were killed off. And then we started to track data of the number of species that were alive as time passed. Okay? So after 1883, you'll notice that the number of species increases here. So in 1908, there were 13, etc., etc. Each row shows a year and the number of species of birds that were observed on that island. This is our data table, and we're going to use that to actually create a graph. Does anybody have an idea of what type of graph we would make? So we could either do a line graph or a bar graph, and actually today we're going to do a line graph. So what else do we do with a data table? Well, scientists look for trends, and trends are just patterns in the data that can explain things. So they make it easier to understand data by creating that graph. Now, let's just make sure we all understand the different parts of a graph. Of course, there's a title. We always want to read this before we create a graph, or we always want to make sure that we've identified a title if it's not already given to us. After that, the y-axis is the one that goes up and down, and the lower value is usually 0, although it could be different from 0 down here. And on this particular graph, it goes up to 40. Notice that each increment is divided by tens. The x-axis, which goes horizontally on the bottom here, usually represents time in most line graphs, although it could be something else. And here we're represented by years. Notice that both the x and the y have labels for the data, as well as numbers. The origin is the point where the x and y meet, and it's the smallest data point a value can have. So remember that it doesn't have to be 0, 0. In this case, the x-axis actually starts at 1880 because we don't have to write a time of 0 since we don't have any data from that time. So other things that you should remember, the x value, the horizontal, is where the independent value, sometimes we refer to that as the IV. The dependent variable is going to always go on the y-axis. So keep that in mind, independent variable on the x, dependent variable on the y. So data table review, remember our independent variable generally is going to be on the left-hand side of the data table, and that goes on the X. The dependent variable then will go on the right-hand side if there's only 2 data points, and that will be represented on the Y. Remember that the X is down horizontally at the bottom, and the Y is the vertical numbers on the left. Remember that the scale of your points has to be even, noticing that these are increments of 10 here, and down here, these are increments of 30 years, okay? And it's always the same if it's the same distance. Again, you don't have to start at 0, 0, and the scale doesn't have to be the same as the points. So sometimes we'll get crazy points and the numbers might not be consistent, like 10, 20, 30, 40. Do not feel the need to just write the points 17, 23, 47 just because they're given. Make sure that they're always even increments going up. Okay, so now we're going to graph. If you look on your handout, you will see a graph on the right-hand side on Unit 1, page 5, and we're actually going to plot these points. So at 1883, there were 0 species. So we're going to plot that point. You'll notice the red dot here at 0. If this is 1880, 1883 is relatively close compared to 1910. So as long as it's within, the first start here, you should be good. Next, in 1908, there were 13 species. So in 1908, so it's just a little bit before 1910, and then we're going to go all the way up to around 13. Remember, if this is 10 and this is 20, halfway is 15, so it's not going to go past there. It's a little bit less than halfway. In 1920, there were 28 species. So 1920 is going to be halfway between 1910 and 1940. And then we're going all the way up to 28, so almost to the 30 point. In 1950, there are 34. Okay, so again, that's close to between 1940 and 1970. And there are 34, so it's almost halfway. And then finally, in 1985, there are 38 species. So we go close to 2,000, but not quite there yet, and almost all the way to the top at 38. Hopefully that was relatively easy for you. That's a pretty simple graph, but you have to make sure that you're plotting points in the correct locations. Okay, so just double check your work here. You have all those points, and is that generally the shape of your graph? If not, make sure you ask your teacher for help. So let's just go through this. Why do we connect the dots? The connecting lines allow you to visualize the trends in the data. Which statement best summarizes what we just saw in the graph? A, land birds have been unsuccessful at colonizing the Krakatoa Islands since 1883 eruption. B, colonization by land birds has steadily increased the number of species since the 1883 eruption. Or C, land birds colonized the islands immediately after the eruption, but the number of species has steadily decreased over the past century. Does anybody know the answer? Hopefully you guessed B. Looking at the word unsuccessful, that means they didn't breed. There weren't very many of them. Looking at the word in C, decreased, shows that the number should be going down. And if we look at our data, what's happening to the numbers? They're increasing. So we have to find the answer that increases, which has to be B. Okay, and that's not on your handout, but I just wanted to show you that. Okay. So, good graphing checklist. Does your graph have a title? Have you placed the independent variable on the X and the dependent variable on the Y? Have you labeled the axes correctly and specified the units of measurement? Is your data plotted correctly and clearly? So if you have all of these things, then your graph should be good. We will do more practice in class, so if there are any questions on this, make sure you ask questions later.